So today's video will be on tree diagrams. Our learning goals for today are by the end of the lesson you'll be able to use tree diagrams to calculate probabilities, and you'll be able to create these tree diagrams. So a tree diagram is a way we can visually represent the outcomes of experiments that have multiple steps. So the tree diagram can only be used if each of your branches corresponds to an equally likely outcome. So something like flipping a coin works well because heads and tails are equally likely to occur. So down the bottom, that's what we've got as our example. So we've got our starting point here, and then we've got the two branches, which are our two options. So when you flip a coin, you can get heads or you can get tails. Then we flip our second coin. So this is coming off each of the branches. So for instance, if the first coin you flip to heads, your second coin you can flip heads or tails. So from there we write our two outcomes. But you could have flipped tails on the first coin, and again you could flip heads and tails on your second coin, and we've got our outcomes there. So we've got our branching off of all the options, all the possibilities that could happen. So let's do a worked example. So 3 fair coins are flipped. So a fair coin just means it's a coin that's equally likely to land on heads as it is tails. So we have to list the sample space using a tree diagram for A. So the first thing we're going to do is flip coin 1. Flipping coin 1, you can get heads, or you could flip and get tails. So this is coin 1. Once you've done that, you flip coin 2. So if you got heads with your first coin, you could then flip heads or tails again. So these are our two options. But if you've got tails, you could get heads or tails again with that one. And that's coin 2. My writing's going up the page. So then you've got our third coin, and you can kind of see the pattern here. So with our first flip, if we got heads and then we got heads again, we could again get heads for the third time, or we could get tails. If we had got tails, we could have got heads and tails again. Heads, tails, heads, tails, and that's coin 3. Now we list our sample space. So we just follow the branches. So we're following the first branch there, heads, heads, heads. Our sample space would be heads, heads, heads. Or we could have got heads, heads, and then tails. Heads, heads, tails. So you're just following each of the branches. So you could have got heads on your first one, and then tails, then heads again, heads, tails, tails. So they are all the options from that first branch if you flip heads first. We've also got that second branch where if you flip tails first, you can get that heads and then heads, or it could go to tails, heads, tails, 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 heads, tails, tails, tails. So you're just following each of those branches out to find your sample spaces. So all the possible outcomes. So I'm probably writing on my face now, I can't see. Sample space. Okay, so B, how many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possible outcomes. C, find the probability that the first coin is head and the next 2 are tails. So how many of those 8 options show heads and then tails, tails? So we can circle them. This option here says heads, tails, tails, and that is the only one. So the probability we get heads, tails, tails is 1 out of 8. D, find the probability that exactly 2 of the coins show heads. So probability of 2 heads. So it's not saying in any particular order, just 2 heads total. So this time I'll do a box. That exactly 2 of the coins. So it's not the first one because that's got 3 heads. This one's got exactly 2 showing heads. That's 1 option, 2 options, 3 options, and that's it. So it's 3 out of 8 of those options show exactly 2 heads, and we can't simplify that, so we'll leave that fraction there. And that's all we have for this video, short and sweet. Any issues at all, please feel free to come and see me in class.